Well, that so solve a new neat code 150. We're currently at number I don't remember 369. It's pretty long days now, so I'm now in almost done with the three problems, and of course I won't really truly remember all of the previous ones that I've solved, but at least that might give me some insights on how to answer them next time. Of course, I'm gonna forget all about this, but no, still, I enjoy doing this as just a side thing from solving problems. It's a thing that I could at least practice and build. If I keep doing it, I know I'm gonna get better. So right now we're gonna solve this problem called construct binary tree from pre-order and in-order traversal, which is a medium problem, and seems we are given two integer arrays, pre-order and in-order. Pre-order is the pre-order traversal of a binary tree, and in-order is the in-order traversal of the same tree. I think I'm not sure how pre-order works. I think in order is one left left and pre-order is one right right. But yeah, I think I can watch the neat code video since I have no idea how this works, and I guess I'm supposed to construct a binary tree from based on the pre-order and in order arrays. I'm supposed to create one. One, two, three, and then null, null, null. Four. Two, one, three, four. Yeah, two, one, three, four. So, yep, let's see. And I'm I'm some something. Yeah, yeah, very good.
Hey everyone, welcome back and let's write some more neat code today. So today let's solve a pretty fun problem, construct a binary tree from a pre-order and in-order traversal. So we're actually given two integer arrays representing one, the pre-order traversal, and two, the in-order traversal of a binary tree.
I'm pretty sure in order follows left and then right. I guess yeah. Yeah. Kind of like this one, 930, 50, 37.
And
I
our
still don't know.
goal is to take these two traversals and the orderings of those nodes and then reconstruct basically the original binary tree that the traversals are from. And it is technically possible. These two traversals have all the information we need. We just need to take that information.
So pre-order is level because I can see it's 930, and in order is starting from like uh how do I say this? Like the height, or like let's say a big line here, 9, 3, 15, 27. So like it orders from up to down, from left to right, while pre-order starts from top to bottom. In order starts from left to right. Maybe that could be the answer. And yeah, 3, 9, 20, and null, null, 15, 7. Yeah, it could be. It could be.
And then deconstruct it and then reconstruct this binary tree from those. So just to verify it, let's go through this tree and actually do the pre-order traversal first of all. So first we know pre-order traversal is you start at the root and then you process the current node, then you do the left subtree, then you do the right subtree, right? So let's just do the pre-order traversal. So we're starting at the root. We do the root node first. That's how pre-order works. So then we get a 3. Next, we're going
Go
to go
left,
to the left subtree and then do pre-order traversal on that left subtree. We
9.
see 9, right? So we're going to add 9 to our pre-order traversal, and it doesn't have any children, so we're actually
Go
done
back,
with 9. We're done with 3. Now it's time to do the right subtree in pre-order traversal. So we start at 20,
start with
add
left first,
20
then right.
to our pre-order, go left, we see 15, add 15 to the pre-order. 15 doesn't have any children. Now we go to the right subtree, 7, so add 7, it's our last node to the pre-order traversal, right? And this actually, take a look at this, take a look at all the values. It matches exactly with the input. So this is the preorder traversal. Now let's just validate the in-order traversal as
Oh,
well.
sorry.
In-order traversal is we start at the root, right? We take care of the entire left subtree first, then we
Then
take
remove
care
them.
of the root node, and then we take care of the right subtree with in-order traversal. That's the general order. So let's
Okay, so pre-order starts at the root, goes to the left. If it's any of the left node has no children, we go to the right, left again, then right until there's no children. So while in order starts at the root, we get the left one to be put, then we go back, then we process all the things on the right, then go to the left again. So we prioritize the left ones first, and then go to the root. And so it's kind of like the triangle. Triangle. It prioritizes the left one, then second one's the parent, the tree, the ancestor, and then the sibling, the right.
validate the in-order traversal of this tree. So we're starting at 1, or we're starting at the root 3, but we're not going to add 3 yet. First, we're going to do the left subtree. We see we have a 9. The 9 does not have any left
How do you
or right
construct a
children, so
binary
now we
tree?
can add that 9 to our in-order traversal. Remember, we're doing this in order, left to right. We go back up to the root. Now we can process the root. We can take 3 and add it to the in-order traversal. And now we're going to do the entire right subtree. So we get to 20, but
Not yet.
we're going to wait for
We
20.
get the
We're going to
left one
first do
first.
the left subtree, 15. 15 is the only
Kind of
value
like a
here, so
triangle.
it doesn't have any children. Add 15 to the in-order traversal. Now we can add 20 because we've done the left subtree. 20 is added, and then last we go to the right subtree, only one value, 7. Let's add that 7 to our in-order traversal. Now let's take a look at these 5 values. Notice how they are the exact same 5 values in the exact same order as that in-order
Now, how will
traversal
we
that we
make
were
that?
given. So we can see that what they
I guess my initial idea on how to create the output based on these two alone could be we first start with the pre-order by by following its footsteps. I have no idea, but yeah, based on in order, we can find out which ones are null, and we could also find out which ones are null based here as well. But yeah, I guess I'm gonna need to. Yeah, there's gonna be more explanation to the problem, anyways.
gave us was correct, but now the question remains, how can we actually take these two arrays, these two traversals, and construct this tree? Well, it's definitely possible. Let me show you how to do that right
Okay,
now. So I just want to
okay,
let you
okay.
know that there's actually two main facts that we're going to be
Breadth or
using
depth?
to construct this tree. So the first fact is that the first value in pre-order traversal is always going to be the root,
Root.
right? We remember when we do
Yeah, and while in order prioritizes the left of the root or the left of the an ancestor.
pre-order traversal, right? We're always processing
So if we could say 3, 9, and then let's say this children has 8, we wouldn't process this first. It would be 8, 9, 3.
the root first. So if I was taking the pre-order traversal that we're given, right? We remember this is the pre-order traversal that we're given. The first value in pre-order traversal is always going to be the root. So this is the first value 3. It's guaranteed to be the root because that's how pre-order traversal works. The first value in pre-order traversal is always the root node. Now we don't know about the rest of these, right? But we can recursively construct now the left subtree and the right subtree, right? We're done with this 3, right? Now our goal is to reconstruct the left subtree. Hey, lucky for us, the first value here is always going to be the root of the left subtree, right? because that's how
Yeah.
preorder traversal works, right? So that's one thing that we're going to use. The first value is always going to be the root, and then we can take the sublist, right? We can remove the 3. We don't need to look at it anymore. Then we take the sublist, and then basically we're going to do this recursively. That's what I'm telling you. Okay, we
Version.
can construct the root, but we need more information than that, right? And then let's say we're done looking at this 3 now. I want to take this uh, array, right? And I want to know which values are going to go in the left subtree and which are going to go in the right subtree. From looking at the actual tree itself, we know the answer, right? We know that
Yeah.
this is where we're going to cut our list, right? The 9 is going in the left subtree, right? These 3 values are going in the right subtree. But how can we determine that? Well, that's what we need
In
our
order.
in-order traversal array for. Okay, so now let's take a look at the input array we're given for the in-order traversal. And
Okay, so what I can draw here is that 3, and since it's 9 and 9, we could say that if a certain number here, like 15, 20, could like reverse it. Nah, I don't know what I'm talking about.
by the way, let me just mention that every value in the traversal is guaranteed to be unique. That's true for both of the traversals, the in order and the pre-order. Every value is going to be unique because every value in the tree is going to be unique. But okay, so far we know that this first value 3 is going to be the root, right? So now let's find 3, right? We know 3 is the root, right? So we removed it from our first list basically, right? But now let's find it in our in order list. We find it's right over here. 3 is in this index, right?
Yeah,
So we know we don't need this 3 anymore, right? We already created that
8. Hold on yet.
node. But so now, what does this in order array tell us? Notice how this is convenient for us. Every value to the left of the 3 that we just created the root from, every value over here, which is only 9, is going to go in the left subtree, and every value to the right of 3 is going to go in the right subtree. That's really convenient,
I
given that we
wasn't paying
just
attention
created the root from. Every value over here, which is only 9, is going to go in
to
the
the
left
left
subtree, and every value to the right of
of
3
the
is going to
root
go
is
in
gonna
the
do the
right
right
subtree.
sub
That's
3.
really convenient for us. Why is this
Oh,
the
it's a
case?
pretty good.
Because that's
Yeah.
basically the purpose of in order traversal, right? It guarantees that we're going to go through the tree in order, right? From left to right,
Uh,
basically. Right? So if we
I
see
mean,
the 3 here, and this is the position in the array, we know everything here is going to be in the left subtree, everything here is going to be in the right subtree. That's what it tells us. This is really convenient for us because we can count it, right? We can see there's exactly one value that's going to go in the left subtree, and there's exactly 3 values that are going to go in the right subtree. So what we can do is we can take the remainder of
pre-order.
the pre-order array and then partition it,
Just put
right?
it in
Partition
the
it over
left.
here because we know one value is going to go in the left subtree and 3 values are going to
Are
go in the
going to
right
the.
subtree. So that's what we're doing,
Oh,
and we're
so
going to
it's
continue.
gonna recursively do that once it gets that in order part and now identifies the left and identifies the node values that are supposed to be at the left or the right. And now we get, for example, 3. So we get 9 now. So this 9 one is in the left here in the in order. So by that logic, we can construct the binary tree now by putting 9 here and then putting these one are the right, we put them in the right now. We started again, we recursively do the right one, 20. And then since it's pre-order, we can know that it goes to the left first before right.
Continue this, right? So now let's and by the way, in the code, we're going to do this recursively. Let's create the left subtree. We know that, okay, this is the in order portion, right? And this is how we're going to partition it from pre-order, right? We see this is the array to create the left subtree. The thing here,
I'm sorry, I had to gamble. Oh man. Take a break.
Here is, notice how this is size 1, right? There's only one value here and there's only one value here, right? That tells us that the subtree we're creating is only going to have one node in it, right? So 9 is the only node in the left subtree. So we're going to create that node, put the value there, and now we're basically done with this left subtree, obviously, because
We're
there's
going on the
no
right.
more there's no more nodes left
I
in
still don't know
this
how to do
general
this in
area, right?
code, not gonna lie.
These values are reserved for the
This
right
thing's really
subtree.
hard.
This is reserved for the right subtree. Okay, so now we're looking at the pre-order portion, right? There's 3 values, just like in the in-order portion. And remember, how are we going to create the root node of this subtree? Now, we always take the first value in pre-order traversal. It's 20, right? The value is 20. So we're going to take this value 20. We don't need it anymore because we're going to create a node from that value. And so now we need to know which values are going to go in the left subtree and which are going to go in the right subtree. We know by finding 20, right? 20 is the value. Let's find 20 in our in-order traversal. It's over here. By the way, in the code, I'm going to be calling the index of this mid. So M for mid. We find the index of 20, right? We know we don't need 20 anymore, so we can get rid of it, right? We see that there's one value on the left of 20 and there's one value on the right of 20. This tells us that there's right, right. So and here, by the 20 is the value.
Oh
Let's
my
find
god.
20 in our in
So
order
like we can
traversal.
pretend
It's
that
over
20 could be
here.
the root.
By the way, in the code, I'm going to be calling the index of this mid. So M for mid. We
The
find the
midpoint.
index of 20, right? We know we don't need 20
We'll know it's
anymore,
always
so
be a
we can get
midpoint based
rid of
on an
it,
order.
right? We see that there's one value on the left of 20 and there's one value on the right of 20. This tells us that one value is going to go in the left subtree and one value is going to go in the right subtree, right? Just like we have over here. So now let's construct that left subtree. We know it's going to be exactly size 1 from looking over here. So we take this 15, right? Now our job is to recursively create the left subtree. We're going to take this 15 since it's the first value in the subarray for preorder, right? We know that it's going to be the root of the current subtree we're at. So let's get rid of this 15. Let's create that node, right? 15
The
over
left one.
here is going to be a node. And there's no more values left in this subtree because we know it's only going to be size 1. Okay, now we're creating the right subtree. We know that there's only one value in the right subtree from looking over here. And since there's only one value left in general, it's a 7. We can make a node from it and then we're done. We know we're done because we've basically gotten rid of every single value in our arrays, preorder and in-order. So using these 2 arrays, we were able to create our tree correctly. And let me summarize what we're actually doing. We're not doing a lot. We don't need a ton of information. Remember, the first value in
Will
preorder,
always
the
be the
preorder
root.
array is always going to be the root, right? That's just how it works. And then once we take that value, create a node from it, and then when we try to look that value up in order traversal, right? Then we can get some subarrays, right? We can take the length of the left and right subarray. So the right subarray is 3 and the left subarray is 1 node. Now these
And
counts
that's
1 and 3, they tell us how to partition the pre-order traversal. So take a look at the
I'm
pre-order
getting confused
traversal.
now.
1 tells us that we're going to cut over here because this needs to be
Oh,
size 1, this needs to be size 3. And then from this subarray with only one value,
let's
we are
go
going to
to the left.
recursively run the algorithm to create this left subtree. And with this subarray, we're going to recursively run the algorithm to create this subtree. And we're just going to continuously repeat that process until we get to our base cases and until we're finished with every single node that we need to create. So now let me actually show you the code. It's actually very short, less than 3
Really?
lines. Okay, so
Less
as
than
I
10
mentioned, this is
lines?
a recursive algorithm. So we always want to start with the base case. And the base case is going to be, what if we don't have any nodes to traverse through the two arrays that we're given? That means we can return null, or basically we don't have
So
to
if not
create a
pre-ordered,
tree. So if preorder is empty or in order is empty, then we can return null. We have no values, so we don't need to create a tree. We can return null. Otherwise, we're going to create a
mm,
tree node, right? And what's the value of that tree node going to be? Well, it's going to be
also, oh my God, learning JavaScript made me at least understand how classes work. Well, maybe not in Python, in JavaScript, because yeah, there is JavaScript, but yeah, root equals tree node, and we're gonna classify it with
be
the
the first
pre-ordered
value that happens to be in the pre-order array, just like I showed you,
at
right?
index
Always going
zero.
to be the first value, so it's always going to be index of 0. And then whatever that value was, we want to find the position of it in the
In
in
order.
order array. So
So mid
in order
equals
dot index, so we want the index of that value,
mid equals oh
pre-order of
okay, okay.
0, and we're going to get it in mid. Now, this is the part where we're going to build the subtree. So root.left, let's create the left subtree, and
Yeah,
we're going to do
actually
this
I'm
recursively,
let's
as I
watch first
mentioned.
before I
So
answer.
self.build tree, we're calling the function that we're inside of. And the convenient part about Python is we can do sublists, so that's going to cut down our
Wow.
code quite a bit. So we need to pass in the new pre-order and in-order arrays, or these
New
subarrays, more likely. So pre-order, what are we going to pass in for the left subtree of pre-order? Well, mid tells us how many nodes we want. The index of
how
basically
many
the value of
numbers
mid
in the
tells us
left and
how
the
many
right?
nodes we want in the left subtree. So what I'm going to do is, for pre-order, we're going to start at index 1. We're basically
Right, right.
skipping the 0 index because we already just created a node for the 0 index. We're starting at index 1, going all the way up until mid plus 1 in Python. This mid plus 1 is non-inclusive, so this subarray is really just a pre-order from index 1 to mid. So that's what we're doing, and we're going to pass in the in order
Hey, let
plus
me
1 is
focus, let me
non-inclusive,
focus.
so this subarray is really just a pre-order from index 1 to
Up until
mid.
to mid plus
So
one.
that's what we're doing, and
The order we're gonna build a tree using pre-order starting from one until mid plus one. How can I imagine this? So so starting from we build a tree from where the pre-order from one up until to middle.
quite a bit. So for the left subtree of pre-order, well, mid tells us how many nodes we want. The index of basically the value. We're going to start at index 1. We're basically skipping the 0 index because we already just created a node
Yes.
for the 0 index. We're starting at index 1, going all the way up until mid plus 1 in Python. This mid plus 1 is non-inclusive, so this subarray is really just a pre-order from index 1 to mid. So that's what we're doing. And
So that would be nine then. It'll get nine. Pre-order at index one up until to oh, this is a doozy. What the hell does this code do? I don't even know what the hell I'm doing. So mid. Okay, so mid get the index of pre-order at index zero. So that means it's this one. So it gets nine, I guess.
we're going to pass in the in order portion that we need as well. And that's just going to be from the beginning up until mid,
Mid.
but not including mid, right?
Yeah, so
This
that means it's
probably
the first
makes
one.
more sense if you go back and look at the picture, but basically we're just creating the appropriate sublists that we need to create the left subtree. We're going to do basically the exact
Will
same
that
thing
right
with the right
self that
subtree.
will
And I would
tree.
encourage you to draw this out yourself to
Okay. Okay. So root dot self. Starting from pre-order up until one, up until mid plus one, but that's from mid till one, so pre-order. So we get the mid. This is the mid now. It's the mid. It's the location of the mid. It's one. So one, zero, one, up until to mid plus one. Technically, this is mid one up until mid, but this is mid. So does this get the two to build this one? I guess so. And then the order version, which is up until mid, since this one's the midpoint, so that means you also get the uh yeah, right.
pair inside of at index in order port watching me do right now. So
And then for root dot right, I can I'll try to answer this on my own. So order. So now that we're making the right one now and the in order version, we're supposed to go from so this is in order, and at index one, starting from no, one mid plus two. Right, just yes. So I guess mid up until mid plus one, and it could be in order. In order is gonna get the rear, so I mean, it means one until mid plus one. Man, this one I forgot how this works, but I know it's non-exclusive, so one is your one this one. So that means it get it's probably wrong, but let's see.
inside of and great sense if you go back and the right subtree, we need every value after this sublist, right? So
Yeah.
we can just say
Oh yeah, we're supposed to cut it. So yeah, this isn't getting those this isn't getting the specific values, actually cutting it. So this one should actually fix. Yeah. So the left one from here, we cut starting from one up until mid plus one, and this one doesn't include the tree. So that means with this one, we cut it off and know that this two will be part of the left. and in order starts from zero up until mid, so it includes this one, these two. While for the right, we're supposed to cut off starting from mid up until up until how do I answer this? Um, So this is mid, and we're supposed to get this one's mid plus one up until that. I guess. But let's see what went wrong with
And
our. I don't know
is
the answer.
creating the list. That's how you do it in Python. We're starting at
Hey,
mid
I did
plus
it.
one and going
I
until
knew
the
it.
end of that sub list.
And while in order, yes, correct. It's correct. So for while in order, it's gonna be the same as well. Yeah, mid plus one again. Since yeah, this one's mid again, right? This one will always be mid.
Order create sublist, right? So, right from our in order array, we want every value to the right of this index mid. So we can do that with mid plus one, starting at mid
Right
plus
until
one,
end.
and then going until the end of the array. So now let me close this
Ahaha!
function. And so this is
I
literally all you
doubted
have to
myself for
do.
a
The
bit.
reason it's so easy is mainly because I'm using Python, but
Yeah, it's
you could
slicing it.
you could do this code without Python. It would probably just be a couple extra lines. You might need to pass in a couple extra parameters into this build tree function, basically just these indices that I'm doing. You might not be able to create sublists, but you can at least pass these indices into your functions in Java and other languages. So with that, we have actually created our tree. So the only thing left for us to do is
So
return
let's
that tree.
turn
So with that
root.
being said, this is the final solution. It's probably less code than you would have predicted, but the problem is a little tricky, but it's
Wow,
kind of
that's
enjoyable, at least in my opinion. So I
interesting
hope that
problem.
this was helpful.
And it's
If you
gonna
enjoyed,
be mistake. I know it. This piece of poop. Piece of poop.
from our in order array, we want every value to the right of this index mid.
Oh,
So
that's
we can do that with mid plus one.
Yay! Anyways, thank you for watching. Goodbye.